go.
So today we've got like sort of a triple lesson of three things that all just tie together. The first one is really pretty easy, but it'll be new to your life, I think. Middle is kind of medium to easy. The last group it's the hardest of the three groups. I don't know that I'd say it's like hard, but the difficulty will build as we go. But it all involves a thing called rates. Okay, so rates are a way that ratios get used. So let's think back to ratios. We had a lot of ways we could write ratios. Somebody remind us of a way we could write a ratio.
The colon.
The colon. Okay, so we did a quiz on that recently. Some of you guys are making corrections on those quizzes. But yeah, we could use a colon to write ratios. That's true. Another way we can write ratios.
Fraction.
We can make fractions, and that's what we're going to do today. That's the most common way we can do ratio. Anytime you have a fraction, you can turn it into decimals. So we wrote some ratios with decimals. And then there was also a word we could use. Just the word two, T-O. But today we're doing fractions. So here's the ruling on these rates today. We're going to want to put a number on the top and a unit on the top, as well as a number on the bottom and a unit on the bottom. By unit, I mean what? What's a unit? A unit, when we're talking about like stories from life or measurements or amounts of things, can anybody give me an example of a unit? Draw the blank. As soon as you hear it, you'll be like, oh, I knew that. Like inches is a unit. This is a unit. Yards is a unit. Get me two more.
Miles.
Miles. One that's not involving length.
A minute.
Minutes, hours, days, weeks, pounds, all that stuff. Units need to be nouns. But units are a thing that give a measurement sort of like a value. Like if you'd say to me, how long do I think the homework's going to take today? And I say, oh, like 1. That doesn't help you. That might be really good news if I meant 1 second or 1 minute. It's not good news if I mean 1 hour or 1 day or something like that. Units are nouns, measurement systems, words that give things sort of like a sense of what they're worth. But anyway, we're going to need a number and we're going to need a unit on the top and on the bottom, and they're going to tell you a little story and you're just going to write a fraction. So if I say 55 miles per hour, like in your car on your speedometer, you're going 55 miles per hour, we can write that rate as a fraction. Can anybody take a shot at what you think we put on the top? There is a 55 on the top, absolutely. Whatever you see first is going to go on top. So we see a 55, we've got a 55 on top. That's true, we're a step of the way. I'm not going to do a 60, I don't see a 60, we're not going to need to get too creative with this.
Excuse me.
Yeah? No, we don't. Yeah, it all worked out, you're good.
Wonderful.
Yeah, I meant
okay.
to come down and tell you that, but we got
That's
all
okay. I'm sorry
quite
to
distracted.
interrupt.
No, it's fine. You get to have your voice on an official YouTube video later.
What's that?
I said, we're recording, so your voice will be on it. You're a
Oh.
special guest on DMR the Math Wizard today.
I'm happy to be here.
That'll boost my views.
Have a good day.
You too. Another thing we could add in here? Yeah. No, you got too creative. You're making it harder than it is.
Miles.
Miles. 55 is miles. So there's a number on the top, there's a unit on the top, we're halfway home. With something we'll stick on the bottom from the second half of the story.
Per hour.
Hour, as we see that word. The only thing that's a little bit tricky about this is we don't see a second number, so you have to understand there is a second invisible number there that I didn't write.
60.
No,
100.
no,
1.
1. Okay. If we're doing 55 miles per hour, that means in every 1 hour, we're gonna travel 55 miles. So the way we could write this rate is 55 miles on the top, because I said that first. 1 hour on the bottom, because I said that second. I didn't say there was 1 hour, but it's implied. If you don't see a number, just use a 1. I understand why you want to go 60, but we are not talking about 60 hours. You'd be talking about 60 minutes. If you wrote 55 miles on top of 60 minutes, that would also be correct. But an unnecessary harder change, you don't need to make that change. Just go with what you can see. But if you change 1 hour to 60 minutes, that is correct. That's not a problem at all. Baseball fans. Just to explain baseball, if you're not a fan, but baseball fans would do better on this. Baseball, if you put the ball in play and get on base safely, that's called a hit. An at-bat is a baseball unit. That's just your turn at the plate. Every time you get up to the plate, that is your at-bat, is what that's called. It's 2 words, but it describes one thing. You know, kickball. You out in gym for kickball, it's your turn, you are at-bat. That is your at-bat. That is a noun. So if we go ahead and write a rate out of this, what's that going to look like?
3 hits,
3 hits on the
10 at-bats.
3 hits on the top and bottom. 3 hits is going on the top or on the bottom?
The top.
Top. Why top?
Because first.
It's first. And then on the bottom,
10
10
at-bats.
at-bats. So we don't want to overthink this. Just the first thing you see, you write it on the top. Second thing you see, you write it on the bottom. But we need to make sure we have a number, we have a unit. We have a number, we have a unit. We've got 4 items to fill. Tax rate. You know, if you're not in Allegheny County and you pay sales tax, it's 6 cents for every dollar. So if I want to write a rate that describes that, somebody jump in, what's going where?
6 cents is going.
6 cents is going on the top. And if you want to write out the word cents, you can. If you want to use some abbreviations, I don't object to abbreviations instead of words. I think I'll just go words because it's less confusing if I'm a little more consistent. What do you think for the bottom? $1. We didn't have a number, so just use a 1. We have $1. This next one usually trips people up because of the construction of the sentence, so I'll warn you about that in advance. Let's do the numbers first and worry about the words second. Somebody with an opinion on where the numbers should go? Shouldn't take that long to do the numbers.
9 on top.
9 on top because it's first.
10 at the bottom.
9 on the bottom because it's second. Sometimes what trips people up is the units. So we'd have to be either brave or wise or both. Anybody have a thought on something to put somewhere?
Americans on top.
I wouldn't do the Americans on top, no.
Milk on top.
Something about milk on top, yeah. But we're not like, you're not getting 9 milks, so we don't want to like say there's 9 milks because we're not being handed milk.
Drink on top.
Something about drink should probably be on top, I agree with that.
9 drink milk.
Yeah, but we want to turn that somehow into a noun.
9 Americans drink.
We need milk in there though. Let's do the Americans. Where's the Americans going to go? It's not. It's on the bottom, okay? What this is telling you is, if you grab 10 Americans, and I don't think this is true, because this seems high to me, but this sentence is telling you, if you went on the street and grabbed yourself 10 Americans and looked at your group, in that group, what will be true within that group?
9 of them drink milk.
9 of them drink milk. What noun would you call those people who drink milk? Now this became more of a grammar question.
Chopper.
No. What would you call a person who drinks milk?
Oh wait, milk lover.
Well, it's warmish.
Milk
A
drinker.
milk drinker. So there's 9 milk drinkers for every 10 Americans. Don't get too hung up on that one. You don't usually get quite so grammarly on things, but first number always goes in the top. Second number always goes in the bottom. If you don't see a number, put a 1. And then make sure your words are nouns. So the 10 Americans went together. The 55 miles, the 3 hits, the 6 cents. This sentence just got a little bit complicated because prepositions changed the order of your sentence around a little bit. So the 9 people, to describe them with a noun, I guess you could say 9 people who drink milk, but it's a little shorter to call them milk drinkers, I think. The units need to be nouns. That's the story on that. Question about that part of the world? You ready? You want to turn? Middle part shouldn't be too hard either. What we're going to do is we're going to multiply some rates. So multiplying fractions, what have you done multiplying fractions in your life? How do we multiply fractions?
Cross.
Go straight across. What can you sometimes do is like a shortcut to speed life along.
Cancel.
Cancel. So what we're going to be able to do is multiply and cross like we always have. You can cancel like you always have, but you're allowed to cancel units as well. If we go to multiply with rates involved, units are allowed to cancel. When can you cancel things? If there's 1 on the
Top.
and 1
Bottom.
on the bottom. If it makes you feel better to make this a fraction, you could always put it over a 1. So I don't remember if the book does that or doesn't do that for you. I don't care if you don't do that, if the book didn't do it for you, but you could do that if that makes you feel better. But if we go to work this out, I don't want in my answer to write like 12 million words. Some of these words are going to cancel out. In this one, what words would cancel? Hours. We have hours on the top, we have hours on the bottom, so we don't need to be talking about hours. We only need our answer for the words, the units, to be talking about months, because that's the one we didn't cross out. In terms of the math, just do the math as always. Multiply straight across. What would your number there be? 24. I thought that would be the medium thing. Maybe this is actually the easy thing. We seem like we got hung up a little bit on that today, but that's okay. So this one, we can cancel hours. So the answer would have to do with the word
Dollars.
dollars. And then the magic number is 30. Question about that? So this, we're going to cancel
Teachers.
every student screen come through. We got rid of all the teachers. No teachers left. So the word for the answer,
Teacher. Students.
students. Not 150. A bunch of people, if I said, what is it, would yell 150, and I'd have to say, no. Why no 150?
Because they basically have every 2 teachers. So
Yes. There's a 2 hiding down here on the bottom. So there's a couple things you could do to try to manage that too. Suggestion.
You could do 15 times 5.
Yeah, because what did you do with the 2 then?
I divided 10 by 2.
Yeah, we can cancel the numbers. We canceled the units today is new. We've been canceling numbers forever. 2 and 10 can cancel, and that leaves 5. So we could go 15 times 5 is 75. Another thing you could have done is just gone straight across. If you did want to go straight across with 150, or 15 times 10 to get 150, if you went straight across to get 150, who would be on the bottom?
2.
2. And then how do we fix that?
Box the
Improper.
top.
Box the top. We divide, you'd still get 75. Question about that? We'll do one more turn. So the last thing we're doing is a thing called unit conversions. So the way unit conversions work is we're going to make a problem like we just did in that middle column. Okay, we're going to create a multiplication problem where we're going to multiply a rate. That's going to cancel the first unit we started with, and it's going to create ourselves a second unit. So here's how I'm gonna go about doing this. The problem mentions 3 feet, so I'm gonna copy 3 feet. And if it makes you feel better, you can always put that on top of a 1. I'm gonna multiply. I'm gonna make myself a new fraction. I wanna cancel feet. So how am I gonna create an ability to cancel feet? Where would I have to put somewhere here for feet to cancel?
You'd have to put a 12.
No numbers, just put feet first.
The bottom?
Bottom. I want to put feet on the bottom because tops can be canceled by bottoms. On top, I need a word. What's the only other word in this story that we can see? Inches. So I'm going to put inches on the top. So that's how I'm going to create this rate. The original unit's going to go on the bottom to cancel, and whatever I'm trying to create is going to go on the top. Then you have to know something, or the book has to tell you something. What's up with inches and feet, and like how they relate to each other? How do inches and feet go together?
Inches go to feet.
Yeah, like what are the numbers though?
12, each 12 inches equals 1 foot.
12 inches is the same as 1 foot. If you know that, great. If you don't know that, I'm pretty sure in the homework the book tells you all these different relationships. And then we're ready to get an answer. This answer is going to be,
36.
word will be
Inches.
inches. Magic number will be
36.
36. That's not the only way you could do that. Okay? So sometimes I get in small arguments with 7th graders over, they're like, I don't need to do all that work to get 36 inches, I can just figure it out. And I'd say that's possibly true, but if I ask you to change 3 inches into, I'll go back to the 3 feet. If I say I want to turn 3 feet into millimeters, yeah, no, you can't do that, okay? So, just because I picked an easier question to be nice to you, doesn't mean you should ignore my advice that this way of doing it is helpful. This way of doing it is helpful, and I'm going to make you do it this way. If some of you are arguing again, I can turn 3 feet in inches without that, that's fine, okay? If you really want to argue with me about it, then I'll make all the questions be turned in 3 feet into millimeters. You don't want to do that, okay? The system is necessary for us to change these units. If you multiply by rates, it's going to do it. For people that are curious, this is why this is working. Okay, 12 inches compared to 1 foot. Those two things are really the same. If we create a fraction where the top and bottom are the same, anytime you build a fraction where the top is the same as the bottom, what is that fraction really? 1. If you multiply by 1, what happens in math when you multiply by 1?
It's the number that multiplies.
It's the same thing, stays the same where you started from. And that's what we're trying to do. We're multiplying by 1 in like a sneaky way. We don't want this to actually change. We just want to express this in a different way. You wouldn't want me to say, all the homework is due from you guys in like 1,000,000 minutes. That might be true, but that doesn't probably mean anything to you what 1,000,000 minutes is. You'd much rather me turn that into hours, or more likely days. You know, we could make that change. If you understand the system, we could make changes like that. Sometimes you want to change one measurement into another. Sometimes you get a measurement, you know, you measure at your house, this is 90 inches long, I need to go buy some wire, and you get to Lowe's and they don't sell wire by the inch, they might sell it by the feet or yard. You need to be able to change stuff sometimes on the fly, and this will let you do that. I'll do a big problem in a minute, not that it's in the homework, but just to show you why this helps us with maybe some bigger stuff. So here, I give you 400 centimeters, just start with that. If it makes you feel better, you could put it over 1, but I don't care. But I do want you to multiply, I do want to see a fraction, I do want to cancel centimeters, so centimeters has to go on the bottom to get canceled. I want to create meters, so meters goes to the top. And then I need numbers. Again, in the homework, they'll tell you the numbers. They'll be kind to you. relationship, centimeters, meters, how much of one makes the other?
Meters, units, centimeters, 100 times.
Yes, so is it 100 centimeters make 1 meter, or does 100 meters make 1 centimeter?
100 meters?
Makes 1 centimeter?
Oh, no. I thought that. Switching around.
So we, 100 here, so that 100 centimeters make 1 meter?
Yeah.
Or do I want the 100 here so that
Centimeter
100?
goes into meters.
Yes, so this gets the
100.
100 centimeters makes 1 meter. So my answer is going to be with the unit.
4.
Unit, meters, and then let's worry about the numbers. 400 on top can cancel 100 on the bottom. That's a 4. So from there. So this, what am I going to copy first?
1.5 kilograms.
1.5 kilograms. Some people will choose not to, some people will choose to put this
Over 1.
over 1. I'm neutral on that, I don't care. Multiply, make a fraction. What unit is on the bottom? Kilograms, because we want to cancel that original unit. Top, grams. And then again in the homework, they'll tell you what's what. But without me telling you, number for this? What's the numbers for kilograms versus grams? 1,000. Kilos, 1,000, back to our metric days. Then we need to decide, is it 1,000 grams that makes 1 kilogram? Or is it 1,000 kilograms makes 1 gram? Which way is the truth? Opinion on that?
1,000 grams.
It is 1,000 grams makes ourself 1 kilogram. So when we do our change-o, the unit, when we're all done, grams. And then we need to take 1.5 times 1,000. So here's a trick from like 2 days ago that we were doing. What's the simplest way to take 1.5 times 1,000? Do the decimal 3 places. Bounce, bounce, bounce. So that's going to be 1,500. Some of those you could have done with common sense. I understand that. I'll show you a problem now where it clearly shows a structure or it's helpful to do this. But question about these before I go crazy problem? Pick a number 1 to 10. 9. So let's say I ask you to change 9 years into seconds. You're not going to be able to like instantly common sense that one. That wouldn't go well. But if we want to do the system, we'd go 9 years over 1. And in our next level, we want to throw years on the bottom. So years is gone. What does anybody know about years? Nobody's going to know how many seconds are in a year. But what do you know about years? Turn years into something else in between.
Days.
Days. Okay, so what do we know about days, years?
365.
365 days makes 1 year.
Oh.
So we took a step. Then let's take another step. We don't want to have days forever. We want days to cancel. So to cancel days, we put days on the bottom. What do you know about days? Do you know anything about days?
So is this 365 days in a year?
We already used that one.
Bro.
24 hours make 1 day. So 1 day, we can make 24 hours. Is that what we were seeking originally? No, but we're closer. So go again. We don't want hours. So we put hours on the bottom. What do you know about hours?
60 minutes equals an hour.
60 minutes, make 1 hour. Is that where we wanted to get to minutes? No, we're closer. So you go again. We don't want minutes. So we need to put it on the bottom. What do you know about minutes?
60.
How do you know?
60 seconds.
There's 60 seconds, make 1 minute. Did we want seconds? Yeah, so now we just do the math. Chances are here, we might wanna grab a calculator. We don't use calculators a lot, but for this one, maybe you want to, because that's gonna get kinda big.
I don't
You know, 60 times 60 times 24 times 365 times 9, that'd be a lot of seconds. I could have kept going. If I had asked you to do milliseconds or something, then that could have been longer than that. If I had started with like 9 millennia, you know, there's no end to how long I could make this go. But if you have the system down, you can get there eventually. Just keep canceling one unit to trade it in for another, and it keeps changing what it looks like, and we get there. It's harder to do some of the other conversions, like if I wanted to do centimeters to inches, you probably don't even know those numbers. If they do that in the homework, they'd have to tell you. Does anybody know the number for centimeter versus inches?
So, like centimeters and 2 inches?
Either way.
So centimeters and inches, which 100 centimeters equals 1 inch.
No.
Or I think, I don't know.
No,
Well,
it's a
that's
weird
meter,
number.
That's meters.
Yeah, it's 100 centimeters make a meter.
112.
Nah, it's a decimal number.
5?
No, it's 2.54 centimeters make an inch, you know, roughly. There's a bunch of weird numbers out there like that. If the book does any weird ones, they'll tell you, but I think they stick more to stuff you know, like inches and feet and yards and things like that. So here's the scheme again. We came in with rates at the very beginning. You have to write a fraction, put a number on the top, put a number on the bottom, put a word on the top, put a word on the bottom. Through the middle, we're going to multiply some rates. You're allowed to cancel the words as well as canceling the numbers. The third thing we're doing these conversions, I want to see a problem that looks like this on the third group of homework. If you don't show a problem that looks like this, I'm just going to make you do it again. Copy the thing you're given, multiply by a fractional rate, and get some canceling going. We're on 3 pages because this was 3 items. There's not going to be a 1 to 25, it's just letters.
Let's go.
So 282, we're going to do letters. It goes from A to J. That's going to be like the first column of what we did. 282, A to J is just writing those fractions that have the units in them. 285 is in the middle. That was the middle column. That's going A to F. You're going to have some rates and you're going to multiply them and do some canceling. 323 is the last page. It's going to go A to F. We're going to do these sorts of conversions like I did in the last column. So 3 columns from 3 pages for 3 groups of letters. It's probably a little less of the homework than it usually is because there's not a 1 to 25. So A, B, C, D, E, F is 6. 6 is 12. G, H, I, J, there's 10 there, so we're 22 total. So that's probably a better 90 quantity than usual. Anybody question about any of that stuff?
So you